how much topic you in this A levels that is new for you. Otherwise, basic topics and the basic concepts are same like your IGCSE. Just like if we start the new chapter of electricity, because electricity section is divided into two different chapters. One is DC circuit and the first one is electricity simple. So it means that in first chapter we are going to discuss about some laws and some theory, and then in DC circuit we are going to just solve practical applications, right? Just like IGCSE, the practical electricity section. Okay, so starting this chapter, I'm going to mention the topics one by one. So let me know if you know the concept of those topic already, or if you want to revise them again. So let me know. So we will start from that pattern. So your very first topic is related to the same electricity. You know that in electricity, first of all, we need to know about electric current, right? So your first concept is related to electric current, and I hope you know about the basic definition of electric current.
Yeah, it's like the charges being passed around, I guess.
Yes, yes. So the basic definition is rate of flow of charges. IGCSE we also studied electrostatic rest charges, right? But this time we only going to study about moving charges, that is electricity. So rate of flow of charges is known as electric current. And if you remember the SI unit and the symbol for current, so the symbol is capital I and the formula is I is equal to Q over T, right?
Right.
Because word rate itself explains that any quantity is going to be divided by the quantity of time. So that is the concept of rate word over here. And if you want to talk about the SI unit, electric current is ampere, right? So here is the electric current. So this is the basic definition, basic formula, and SI unit of electric current, right? And one more thing that you need to know about, we also studied two different directions for electric current. We can say that one is the conventional current and second one is the non-conventional or electron flow, right? So one important concept is the first one is conventional current. So what is the definition for the conventional current? When charge or any charge start to move from positive to negative side, let's suppose if we are having a positive terminal and once we have a negative terminal, let's suppose if we are having a positive terminal over here, this is a positive, and on the other side we are having a, and we just connect these terminals with the help of a wire. So when charges are going to move from positive to negative side, so this flow of charges is known as the conventional current. So in conventional current, charge can easily flow from positive to negative terminal, or you can say that the direction of flow of charges will be from positive to negative, right? It actually explains you the direction of flow of charges. So this is the basic concept of conventional current, right?
Yeah.
And if we talk about the reverse order, like if charges are going to move from negative to positive, Because in old days when scientists are going to discover new theories, new concepts, new laws, so in that time scientists think that charge will move from negative side to the positive side, right? Because there is a concept of free electrons. But after
But
some time,
the conventional current flows from negative to
uh,
positive, right? No, from
that,
positive to negative.
yes.
And then the electrons themselves move from negative to positive.
Yes, so that's why it is known as electron flow, right? Because protons are in the nucleus, so that's why it is known as high potential. And in our daily life and in our daily routine, we know that everything flow from high to low, right? Just like if we have a steep slope, so if we place a ball on the top side, so ball will automatically roll down to the lower end. If we place that ball on the lower end, so ball will never move in upward direction by itself, right? So everything moved from the higher potential to the lower potential. So that's why after some time they discovered that the direction of electric current will be from positive to negative terminal, right? And if we talk about the electron flow only, so electron flow is known as non-conventional current. And that non-conventional or electron flow tells you that charges will move from, or electrons will move from negative to positive terminal. So that is the concept of non-conventional current, right?
Yep.
So non-conventional current, or the second term that mostly we use, is known as electron flow. Because sometime in exam they ask you to draw the diagram or draw an arrow to show the direction of electron flow. So sometime student got confused that what is electron. So this yellow line represents you the direction of non-conventional current or electron flow. So that is completely opposite to the conventional current. So we say that flow of negative to the positive terminal. Okay, any confusion?
Nope.
Okay, and if you want to draw in a circuit, so that will be also very easy. Just we take direction from negative side to the positive side. We also discuss in detail when we are talking about circuit, because these are basic knowledge that we already know, right? So this is the concept of conventional and non-conventional. And the second thing is, if we already discussed the formula, right? So there is a separate topic to find out the value of electric current. So we already write down the formula for electric current, and that is very simple: rate of flow of charges, and we know the SI unit. So I think that will be also easy for you. There is nothing new in this topic. You know all the symbols Q for the charges, and what is the SI unit of charges?
Coulombs.
Coulombs, yes. So C is the symbol for that coulombs. So that is also simple, right? Okay, now the new topic in this chapter, the first new topic in this chapter is known as if you want to calculate current in a current carrying conductor, right? Normally we calculate current throughout the circuit, throughout the conductor. But let's suppose if you want to calculate the value of current in a current carrying conductor, like we are going to find out the value of charges that are going to flow from that specific part of the conductor. So that is our new topic. That is for the first time in your AS, because that is not included in your IGCSE. So our next topic is calculating current in current carrying conductor. We are studying only electricity section in this AS, and then electromagnetism is going to be included in your A2. So that's why your AS and A2 is completely connected with each other. So your AS is very
Oh,
much important because this is the base for the next A2. So that's why AS is quite difficult as compared to A2. Okay, now if we want to calculate current in a current carrying conductor, so normally we know that if we want to calculate the current, so formula simple, I is equals to Q upon T, right? But we know that there are two types of material. One is known as conductor and the second one is known as insulator. And you already know the difference that in conductor there are free electrons, but in insulators there are still electrons, but they are not free to move. They can only vibrate about their fixed position, right?
Okay.
So that is the difference right over here, because we know that electron, protons, and neutrons, all particles are present in single atom or single element, right? So why only conductor can flow electric current, or why it is easy for conductor to flow heat and electricity through it? Why not insulator? Because electrons are also present in it, right? So the problem is that free electrons are available in conductor, free electrons are also available in insulator. But the problem with the insulator is that free electrons can only vibrate about their position. So that problem, that insulator conduct heat and electricity, because electrons are free, but they are free like they can only vibrate about their fixed position, right? So that is the problem. Okay, if we continue with the conductor, so we know that there is a concept of free electrons too, and in this concept, electrons are completely free to move in all direction. Electrons are free to move in all direction. Talking only conductor, not insulator. And let's suppose if we consider a diagram over here. So let's suppose if we are having a conductor, this is our conductor, and let's suppose we consider some charges in it. This charge, this is charge. So these are some charges which are going to move, right? So if we consider another example of same conductor, and in this example, we are also going to mark the charges, but this time we are having negative charge, one, negative, and negative, right? So in first diagram, we are having a positive charge carriers, and in the second diagram, we are having negative, right? In first diagram, it means we are focused about positive charge, and in this diagram, we are having positive charge here. Okay, now if we consider the first diagram, let's suppose this is the first and this is the second. Now, if we consider the first diagram, so in first diagram, if we consider the direction of flow, so your direction of flow will be towards left hand side, like this. This will be your direction of flow, right? And current is also going to move in this same direction on left hand side. And there is also a distance. Let's suppose if you want to find out the distance of a single charge to the end of a conductor, so you can also measure the distance of the or the length of a conductor, right? So the direction of electric current is from right to left. It means positive terminal is on right hand side, negative terminal is on left hand side. So positive charges are going to move towards negative side, from positive to negative terminal, right?
Right.
Okay, now if we first consider the very first situation for the positive charge carrier. So in your diagram one, in your diagram number one, If we talk about the speed of the charges, right? Or and we are going to use a term drift speed over here. Why we are using drift speed? Because you know that when a charges are going to move from one terminal to the other terminal, so it is going to be in contact with the molecules of the material also, or the atoms of the material, right? Let's suppose if we are using copper, so copper is made up of a copper material, right? So there are atoms and the molecules of copper material also, right? So when charges are going to move, so it is going to overlap the material or the atoms of that material from which conductor is made from, right? So that's why we are going to use the term drift speed over here, because they are going to overlap and going to pass like drag over each other or overlap each other. So that's why we are going to use the concept of drift speed. So in diagram number 1, we can say that the drift speed is in the same direction, is in the same as the current. Because you know that if we want to find out the speed, so we will also able to find out the direction, because vector quantity velocity is a vector quantity. So if we want to discuss about the direction, because in previous stages we are only talking about the magnitude, I is equals to q upon t, that's it. We never talk about the speed of the charges or the velocity of the charge, right? So that's why in diagram 1 the drift speed is in the same direction as electric current. Then number 2, in diagram number 2, what will be the difference in diagram number 2? The drift speed is in direction,
Different character.
direction. The direction of current 2 on that diagram, because directions is not marked over there. Again, we are taking the same direction of electric current from right, and these are negative charges. So you know that negative charges will always move towards positive one, right? So these charges are going to move in this direction. So now you can see that the direction of drift speed is completely opposite as compared to the previous situation. So the drift speed, the opposite direction, is in opposite direction to the current, right? Clear? Any confusion?
Nope, it's clear.
Okay. And if we talk about the drift speed, so basically speed is the average speed the charge carriers are traveling through the conductor. And why we are using the word average? Because it depends upon the other charges. Let's suppose if there is a bulk charges in front of the charge carrier, so there will be high resistance, right? And let's suppose if we are using a good conductor, so there will be less resistance. So sometimes it may be speed will be faster as compared to some specific point, and sometimes speed will be slower as compared to some specific point. So that's why drift speed is the average overall speed throughout the conductor, right?
Right.
So that is the concept over here. And the next thing is we talk about the drift speed, that is a new concept. And second thing is we know that if we are talking about a conductor, so we need to talk about cross sectional area also, right? Because in the concept of resistance we discussed that resistance also depends upon cross sectional area and the length of a conductor, right? So electric current will also affect from the length and the cross sectional area, right?
Yeah.
So
Also, the
yes.
length and the length and the thickness both
Yes, thickness.
affect.
Yes. So that's why we use the cross-sectional area from the side of the conductor, because that will give you the concept of thickness also, right? Because if we are
Okay.
making the area from the front, so we are not able to identify the thickness, right? Because from front we are only calculating a simple area, but if we are calculating from the front of the conductor, just like if we observe our pen or pencil from the tip side or from the back side, So that is cross sectional area. That gives you the idea that how thick that object is, right? In circular form. Just like the opening of any pipe we discuss in the closed column and the one side open air column, right? So that is the concept. And the next thing is there is a formula which is important to write over here, that is also mentioned in your formula sheet that we discuss in past papers, that is given in your past papers too. So we need to know about the quantities which are mentioned in that formula. So the formula is I is equals to capital A is small n V Q. So this is the formula for the drift speed, we can say that, or for the current in current carrying conductor, because the speed is also given in this formula. So you may also arrange this formula for the drift speed, or you may also arrange this formula for electric current. So I is for electric current, you know that this is for electric current. And if we talk about capital A, so capital A will be for cross sectional area, right? This is for cross sectional area. And what will be the representation of N? N represents you. It represents number density. What is the concept of number density? Number density represents you number density of charges or charge carrier, and that is equals to per meter cube, right? It means that we are talking about the 3D structure of that material, right? So how many charges are going to be in that 3D length? So actually we take a specific length of conductor, and we are going to find out the speed in this specific length of conductor. So when we are talking about the length, so we are not taking length in one dimension, because we include cross sectional area. Cross sectional area is meter square, so that is two dimensions included over there, and one dimension is the linear length of the conductor. So when we combine them, so the number of charge carrier present in that specific length, combining the cross sectional area, so that will give you the concept of number density of charges, right? Any confusion?
Okay.
Let's
Oh,
suppose in diagram 1, diagram 2, in diagram 1 there are 6 charges, and in diagram 2 there are 5 charges in a specific length. So that is the concept of number density. And if we talk about V, so V is the average drift speed. This is average drift speed. And the final quantity is Q. So Q represents you charge, right?
okay.
So actually this is the formula, and you can easily calculate the current in a current carrying conductor through any specific cross sectional area or through any specific length. So this is a new concept. There is a new concept of drift velocity in your AS, right?
Right.
And mostly this formula is going to be like one part, like we are doing question number 6, and in that question number 6 there is a single part to calculate the drift speed, or to calculate the charge, or to calculate the number density. So you need to think about this formula, that this formula will help you to calculate these kind of stuff in your electricity section, right?
Right. Okay.
So this is complete topic of electric current, calculating current in current carrying conductor, right?